All right, this is Team 4, and we're doing a portable Geiger counter as our project.
So, what is a Geiger counter? It's a radiation detection and measurement instrument. It consists of a gas-filled tube containing electrodes between which there is an electric voltage but no current flowing. When ionizing radiation passes through the tube, a short, intense pulse of current passes from the negative electrode to the positive electrode and is counted. The number of pulses per second measured the intensity of the radiation field.
And this is a bit of a diagram showing what he describes. So on the left image, you can see there's an initial radiation coming in, and it ionizes the gas-filled chamber of the Geiger counter. And usually this is filled with an inert gas like helium or argon, which are the most common, and they try to avoid negative ion forming gases. And then there are multiple avalanches per ion pair, as you can see on the right image is the example of the avalanches happening, which produce a pulse on the anoid.
So our build specs is that it was a 3D printed case based on the circuit dimensions, so it can fit in the box. It's lightweight and enclosed, while it also provides protection to the detector. It has an LED screen, which you'll see soon, and audible speakers that indicate the integrated to counts per minute. The whole thing costs about like $60, not too bad.
So first of all, this is our case. It's very well constructed, highly durable, perfect at protecting the sensitive electronics. So this circuit is powered by a USB in, which is just connected to a computer. From there, it powers the control board, which sends power to the Geiger-Müller board, which takes the power, converts it into high voltage, runs it across here, and then every time a count is detected, this light flashes, and that click is detected and sent over to the breadboard on this wire. So it goes back over here. It has its input signal, and so this board detects that a click has been detected, sends power over to the LCD screen, which counts a click. This is a little background adjustment potentiometer where you can adjust the background depending on the lighting situation. And basically, it has a little timer programmed into this board over here. And so every 60 seconds, it takes the total amount of clicks that it has detected and puts that as counts per minute. So as you can see, this is background. And so after a minute, it will reset and count back up to 60 again.
So for our Geiger tube, we were able to source the M4011 tube online. It was just a very common tube that fit our needs. It operates at a temperature of anywhere from -100 Fahrenheit to up to 130. So operable temperatures for pretty much any application you could need. It can detect gamma rays and beta rays from down to 0.1 MeVs up to almost 2 MeVs and works at a voltage of 380 to 450 volts.
So this is the process, or like the pre-built process before making the detector. This is the 3D files. The outer dimensions of the box on the outside is 8.5 inches by 5.5 inches by 4 inches, and the inner part of the box is 8.8 inches by 5 inches by 3.9 inches. And here's just another picture of the circuit.
All right, in this, we display the case in this video on the left, showing where our Geiger counter would be placed in, but for demonstration purposes, we have it outside the box. All right, and in the next video, it shows us plugging it into the power source, which can be a laptop or anything that's USB. And it immediately starts counting the background, which is around 30 CPM.
So in this one right here, we can we're detecting the source, the cobalt 60, and you can hear it making the and this one right here is just the background.